So today we're going to finish the perpendicular lines notes. So you should be on page 43 of your notebook, and we're going to do hand out these examples. So I'm just going to go ahead and glue it in now. If, of course, you don't have a printer, you're just writing it down on page 43. You should be having a notebook anyway, whether you are a distance learner or not. Okay. Okay, first of all, we're going to talk about the perpendicular bisector theorem, then the converse of it, and we're going to use it to solve problems. So, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. The perpendicular bisector, remember, cuts it in half at a perpendicular or a right angle. Equidistant is exactly what it sounds like, and that is equal distance. See the that? Equal distance. Okay? So we're going to use that. Use the diagram below. BD is the perpendicular bisector of AC. So that means it cuts it into two equal pieces at a right angle. The perpendicular bisector theorem then says, and I'm going to do this in a different color so you understand where I'm getting this. This piece that I'm going to highlight, that I'm going to mark off, is because of the perpendicular bisector theorem. It says if a point is on the perpendicular bisector of the segment, then it is equidistant from the endpoints of the segment. Here's what that means. Since D and B are on the perpendicular bisector, that means AD and CD are congruent. It also means AB and CB are congruent. That comes from the perpendicular bisector theorem. Now we're going to solve these problems. Suppose ED is 16 centimeters and DA is 20 centimeters. Find DC. They actually give you more information than you need. They said, hey, this right here, and I'm writing with something I can erase with, is 16. This is 20. And they want you to find this. We don't need to know this is 16 because based on the perpendicular bisector theorem, DA and DC are the same. So DC is 20 centimeters. Okay? Something you have to get used to. These problems are not related. So I'm going to erase this. That's why I did something with it. We'll erase because these values do not match now. The relationship is still there. So the things that are marked as congruent are still congruent, but the relationship's not the same. The next one. Suppose EC is 15. BA is 25. Find BC. So the same thing. They gave us extra information. BC is 25 centimeters. Okay. All right, let's talk about the converse. If you remember, the converse is just flipping it. So it's taking what was the if and putting it for the then, what was the then and putting it for the if. So if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So they're already telling you right here that these two are congruent to each other. Well, since these two are congruent to each other, that means this is the perpendicular bisector. So this and this are congruent, and it's at a right angle. Can't see what I just drew? So since this right here, these are congruent, they gave us that in the problem, that means this and this are congruent because of the converse of the perpendicular bisector theorem. So it's kind of the opposite. In this one, we started with the perpendicular bisector and knew the outside segments were congruent. In the converse, we started with the outside segments and knew that right here means that must be the perpendicular bisector. Okay, AD is 10 inches long. BD is 6 inches long. Find AC. Wow, so this one's a little different. So what we're going to have to do is find AB first, and then we can double it since they're congruent. But to find that, we're going to have to use the Pythagorean theorem. Remember, a squared plus b squared equals c squared. Now remember, c squared has to be the hypotenuse. The hypotenuse is across from the right angle, so c squared is 10. And now it doesn't matter if 6 is a or b. I'm just going to say it's a. I should have probably made it b so it didn't look like a 6 and a 6. Okay, so 6 squared is 36 plus b squared equals 100. Subtract 36 and you get b squared equals 64. Take the square root and you get b is 8. Well, that means AB is 8. But to find AC, AB is 8, BC is 8. So that means AC is 16 inches. And I almost put centimeters on accident. $16. Okay. So there are the two theorems we're learning today. What we're going to learn in a minute is a review. These two theorems, the perpendicular bisector theorem and its converse. All right, now let's talk about a parallel lines review. Okay. B is parallel to D. C is parallel to E. The measure of angle 1 is 50 degrees. 50 degrees. The measure of angle 5 is 90 degrees. Use the diagram to find the measure of angle 4. Okay. Here's what I got going on. I know some things. I'm going to move some stuff around. I've got in black what I was given. All right. It does say that C right here is parallel to E right here. Well, that means since C and E are parallel, and they're cut by this transversal, that 1 and 2 are corresponding angles, which means they're congruent. So this is also 50 degrees. Okay. That'll help us some. Here's how that's going to help us. Looking for 4. Okay. 2 and 6 and 5. All of those are on a line right here. That means these 1, 2, 3 add up to 180. So 50 degrees plus, we don't know, plus 90 equals 180. Here's why I want to find the measure of angle 6. 6 and 4 are vertical, which means if I find 6, I know 4. 50 plus 90 is 140. Subtract 140. X equals 40. And then we're going to actually write the measure of angle 4 equals 40. Because they're vertical, so they're the same. Okay, so today your homework will be about these two, as well as sometimes a review about parallel lines. If you did not glue it in, or you did not write on this page, please do so now. And I'll see you tomorrow.